Okay, hello everyone. In a new video, this one we are going to solve an exercise related to optics and the chapters of lenses and formation of images. This exercise was a previous one in the brevet exams in 2012, first session, first exercise. Okay. The title of this exercise is Converging Lens. Consider a converging lens L of focal length f and a luminous object AB of size AB. AB is placed at the distance p from L. Then here the distance p represent the distance object lens, and perpendicularly to the optical axis of L at A prime B prime is the image of AB given by L is situated at the distance P prime from L and of size A prime B prime, and the distance P prime represent the distance lens image. Okay, the table below gives for different values of P the corresponding values of P prime and of A prime B prime. Okay, they mention the table, then I can use this table. However, till this moment they didn't mention anything about this graph, so I'm not allowed to use this graph at all. Okay, all my answers must only be restricted to the given text and this table. Now number 1, part 1. Okay, they are telling me variation of some characteristics of A prime B prime with P. Referring to the table, part A, show that, part I, that f is equal to 10 centimeter. Okay, usually in order to calculate the focal length, we calculate the focal length graphically by counting the number of divisions between the optical center and the image focus and multiplying by the scale. But here I'm not allowed to use the graph. I need to use the table in order to calculate or determine the value of f. So notice that here in this table, for P is equal to 20 centimeter, we have that P prime is also equal to 20 centimeter. So let me write it down. P is equal to 20 centimeter. Also P prime is equal to 20 centimeter. So what does this mean? Let's recall that P represent the distance object lens and P prime represent the distance lens image. In this case they are equal. And we know that whenever the distance object lens, which is P, is equal to the distance lens image, which is P prime, we know that we have the following relation. Since P is equal to P prime, then we can deduce the focal length from the following relation. Then P is equal to the double of the focal length, in which the value of P is equal to 20 centimeter. Okay, now because P is equal to 2f and we know the value of P to be 20 centimeter, we can deduce the value of f by dividing both sides by 2. Then the value of f is equal to P divided by 2. P is equal to 20 dividing by 2, and this will give me 10. Since P is in centimeter, then the value of f will be in centimeter. Always in physics, all quantities must have a unit. Therefore, f is equal to 20 centimeter. Also, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. Now, part 2. Okay, show that AB is equal to 5 centimeter. We know that also on the distance object lens is equal to the distance lens image. Then A prime B prime is equal to AB. They are telling me show that the size of the object is equal to 5 centimeter. Okay, so here in this column, the same column where P is equal to 20 centimeter and P prime is equal to 20 centimeter, we have the size of the image A prime B prime is equal to 5 centimeter. Because P is equal to P prime, then the size of the image is equal to the size of the object. A prime B prime is equal to AB, but we know that the value of A prime B prime is equal to 5 centimeter. Then this will give me that also the size of the object is equal to the size of the image. Okay, so whenever the distance object length is equal to the distance length image, we have the following formula, that P is equal to the double of the focal length, and we have that the size of the image is equal to the size of the object. This only holds whenever P is equal to P prime. Now they are telling me in idea number 3, A prime B prime is real. I repeat that I'm not allowed to use the graph, and I don't have in this graph the image, so I cannot say that the image is inverted with respect to the object, therefore it is real. And they didn't tell me here in the text that the image is collected on screen to say that the image is real. Okay, then I need to find another method. Notice that for all values of P is equal to 30, 20, 15, 12, and 11. All of these values are greater than the focal length, which is f is equal to 10 centimeter. Okay, in part 1, in idea number 1, we have proved that f is equal to 10 centimeter, and notice that all of these values are greater than 10, which means that the object AB is placed in front of the object focus. And the lens L that we are using here is a converging lens. Let's write this down. Since the lens L is a converging lens, and the object AB is placed in front of the object focus. Why it's placed in front of the object focus? Because all the values of P are greater than the focal length. And we know that whenever the object AB is placed in front of the object focus and the lens that we are using is a converging lens, then the image A prime B prime is real. However, if the object AB is placed between the optical center and the object focus, then the image will be virtual. For this reason, then the image A prime B prime is real. Now in part B, they are telling me specify how A prime B prime varies as the object AB gets closer to the object focus. Let me make some space. Now part B. Specify how A prime B prime varies as the object AB gets closer to the object focus. Okay, when the object AB gets closer to the object focus, the distance P decreases. Let's say that as P decreases, they are telling me how does A prime B prime varies. So I need to study the variation of the size of the image A prime B prime. A prime B prime, I repeat, P decreases because P represents the distance between the lens, between the object and the lens, and the object AB is getting closer to the object focus, therefore P will decrease. As p decreases, a prime b prime varies from 2.5 to the next value is 5 centimeter, then 10 centimeter, 25 centimeter, and 50 centimeter. So notice that all of these values are increasing, they are in the increasing order. Therefore we can say that as the object AB approaches the object focus, which is F, then the size of the image increases. Now in part 2 they are telling me give for the different positions of the object listed in the table the direction of A prime B prime with respect to AB. We have proved already that the image A prime B prime is real, and we know that a real image is inverted with respect to the object. Okay, so this is the direction of A prime B prime with respect to AB. Since it is real, which means then the image A prime B prime is inverted with respect to the object AB. Now in part 2 geometrical construction of A prime B prime, figure 1, they mentioned the figure, so now I can use the figure. Shows L, its optical axis X prime X, its optical center O, the object focus F, the image focus F prime, and the object AB. In part 1 they are telling me redraw on the graph paper figure 1 using the same scale. So whenever we need to redraw the figure, we always start by drawing the optical axis in the same direction of that of propagation of light, which is considered to be from left to right. Then we place the lens L perpendicular to the optical axis at the center. Let's label some stuff. This is the symbol of a converging lens, which is L. This is the optical axis X prime X, and the intersection between the optical axis and the lens L is the optical center O. The point F is located 1, 2, 2 divisions in front of the lens, and the point A 3 divisions in front of the lens. The point F prime 1, 2, 2 divisions behind the lens. The point B is located 1 division above A. Therefore AB is the object. Let's trace it. And the scale is given by 5 centimeter along the x-axis and 5 centimeter along the y-axis. So this is it for part 1. Now part 2, they are telling me trace on this drawing the path of a luminous ray issued from B and parallel to the optical axis of L. They told me trace, no need to justify anything. So part A, this is an incident ray issued from B and parallel to the optical axis. And we don't forget arrows on light rays. We know that always incident parallel ray is related to the image focus. Therefore it emerges passing through the image focus like this. So part A done. Now part B. Trace on this drawing the path of a luminous ray issued from B and passing through F. Okay, this is an incident luminous ray issued from B and passing through F. We know that always an incident ray passing through the object focus, it emerges parallel to the optical axis. And we don't forget arrows on light rays. So also done for part B. Now in part 3, they are telling me construct then the image A prime, B prime. Okay, by construct, the word construct means that we need to trace and justify at the same time. Already we have done the rays, so it's left to trace the image A prime, B prime and do the justification. Okay, here behind the lens we have the two emergent rays. We know that always the intersection of the emergent rays is the image of the object. These emergent rays are coming from these incident rays that are coming from B. Therefore, the intersection will be the image B prime of B. Here A represents the foot perpendicular of B on the optical axis. Therefore, A prime, the image of A, will also represent the foot perpendicular of B prime on the optical axis. Let's trace the image. Moreover, here on the point B we have a hat directed away from the optical axis. Therefore, the hat is directed away from the optical axis. Then we must place on B prime also a hat directed away from the optical axis like this, downward. Let me make the hat clear here. Here also on B prime we have a hat. This is the tracing of the image. Now let's do the justification. Then the image B prime of B is the intersection of the emergent rays. Now A prime, B prime consists of 2 points. We have justified B prime. We need now to justify A prime. A prime is the foot perpendicular of B prime on the optical axis. Okay. Let me make some space. Now in part 4, they are telling me determine the values of P prime and that of A prime, B prime. Notice that this part is in part 2 of this exercise, so we will refer to the graph. What does P prime represent? From the title, from the given text in the beginning of the exercise, independent of which part, P prime represents the distance, lens image, and A prime, B prime is the size of the image. Then now we need to calculate P prime graphically. P prime represents the distance between L and A prime, B prime. Now we count the number of divisions between the lens and A prime, B prime. We have 1, 2, 3, 4, 5, 6. And we multiply by the scale along which we have counted the number of divisions, which is the scale along the x-axis. And this will give me 30 centimeter. Then the value of P prime is equal to 30 centimeter. In the same question, they are telling me and that of A prime, B prime, which is the size of the image A prime, B prime. A prime B prime consists of 1, 2, and we multiply by the scale along which we have counted the number of divisions, which is the scale along the y-axis. This will give me 10 centimeter. The unit of A prime B prime is centimeter. Okay, in part 5 they are telling me, are the obtained values compatible with those given in the table? Now if we refer back to the table, we notice that for P prime is equal to 30 centimeter, Y P prime is equal to 30 centimeter, because here from the calculation P prime is equal to 30 centimeter. For P prime is equal to 30 centimeter, the size of the image, so this is P prime is equal to 30 centimeter, the size of the image is equal to 10. And indeed our calculation also give us that A prime B prime is equal to 10 centimeter. Therefore these values are compatible with the table. Let's say that according to the table, for P prime is equal to 30 centimeter, we have A prime B prime is equal to 10 centimeter, which are the same values that we have calculated graphically from part 2. Then the obtained values are compatible with those given in the table. Okay, so that's it for me in this video, guys. Hope it was beneficial for you guys out there watching it, and see you soon in another one.